Assalamu alaikum, 8th graders. Today we are going to be going over 7-8, which is geometric sequences. Geometric sequences, basically a list of numbers that are going in order. Comparing this to arithmetic sequences, which we did in a different chapter, arithmetic sequences have a common difference, whereas geometric sequences have a common ratio. Let's go over the vocab for this lesson. Vocabulary says, underline the correct word to complete the sentence. To write a ratio in simplest form, you're going to divide the numerator and denominator by their greatest common factor. What you're going to do is, if you have a fraction like this one, you have 3 12s, you would divide both 3 and 12 by 3, which is the GCF, and you would get 1/4. And you're going to do the same procedure for numbers 2, 3, 4, 5, and 6. So you're going to divide both 4, 6 for number 3 by 2, because the GCF is 2, and you're going to get 2/3. The 1 and 5 don't have a GCF other than 1, so that's going to stay the same. And for number 5, to reduce this fraction, you are going to divide both the numerator and denominator by 25 to get 4/9. Okay, so what is a geometric sequence? A geometric sequence is a sequence of numbers where the ratio of any term to its preceding term is a constant value. All geometric sequences have a starting value and a common ratio. So you have a sequence 2, 6, 18, 54. This is a geometric sequence because the ratio of any term to its preceding term is 3. So basically, when you take the ratio of 6 and divide it by 2, you're going to get 3. When you get the third term, 18, and divide it by the second term, which is the previous term, 18 divided by 6 is 3. 54 divided by 18 is 3. So as the sequence increases, each term is being multiplied by 3. Now we're going to identify the starting value for each geometric sequence, and then we're going to find the common ratio. So the starting value for each sequence is basically the first term. So for number 6, it's 2, and each term is being multiplied by 2. So the common ratio here is 2. For number 7, the first term is 1. The common ratio is -1, because -1 times -1 is -1, -1 times -1 is 1, 1 times -1 is -1, and so on and so forth. Your first term for number 8 is 1, and your common ratio is 5. Each term is being multiplied by 5. 1 times 5 is 5, 5 times 5 is 25, and so on and so forth. For number 9, your first term is -2, and your common ratio is -2. Pay attention to when you have a sequence where the sign fluctuates, right? You have negative here, positive. Your first term is negative, your second term is positive. Your third term is negative, your fourth term is positive. In that case, that should be a little signal that should go off in your head that says, oh, my ratio is probably negative. But you can confirm that by just dividing the second term by the first, the third term by the second, and so on and so forth. And you'll see that the multiplier or the common ratio is a negative term here. And notice for number 10, the terms are decreasing. So that means you're probably dividing by a number. Now, when we're dividing by a number, we want to write that as a multiplication. We want to use multiplication as the operator. So we're saying that though we're dividing by 2, we're actually multiplying it by a half. It's the same thing, but you want to write it as a multiplication operation. So 1680, when I multiply that by a half, that's going to give me 840. 840, when I multiply it by a half, is going to give me 420. And you confirm that by testing 840 divided by 1680, or the consecutive term divided by the previous term. Okay? All right, so now how do we work with geometric sequences? How are they written up? A geometric sequence with the starting value of A and a common ratio of R is a sequence of the form AR, AR squared, and AR cubed. This is what the terms look like. So you have your initial term. Each consecutive term is being multiplied by the ratio. And then the third term is going to be multiplied by the ratio squared. The fourth term is going to be multiplied by the ratio cubed. So how do we write this recursively? To write an equation like this in a recursive format, the recursive format has 2 parts. You have the initial condition, which is your first term right here, and then the nth term is going to be is going to equal the previous term, or the, like, say for example, if I wanted the seventh term, I need the sixth term, and then I'd have to multiply that by r. The condition is that n has to be greater than or equal to 2. Okay? Because your first term is already written there, it doesn't make sense to put n is equal to 1 as your following term. The next term would have to be your second term. Okay? So that's why that says n is greater than or equal to 2. Another way we can set that up is with an explicit definition. And in this definition, we only have a single formula. A sub n, or my nth term, is going to equal to my first term times my ratio to the power n minus 1. So if I'm looking for, say, for example, the seventh term, I need the first term multiplied by the common ratio, and then I'm going to plug in 7 for n, and then I'm going to simplify that. And then my power will end up being 6. Okay? And in this condition, in this sequence, or in this definition, n has to be greater than or equal to 1. So every geometric sequence has a starting value and a common ratio. And the starting value and common ratio define a unique geometric sequence. How are the starting value of the sequence and the initial condition of a recursive definition related? The starting value, a, is equal to a1 in the initial condition statement. And a sub 1 is really just written in the recursive formula, so pay attention to that. Now let's go to problem number 2. Let's go to problem number 1, identifying geometric sequences. Which of the following are geometric sequences? If the sequence is not geometric, is it arithmetic? So remember, if it's geometric, it has a common ratio. If it's arithmetic, it has a common difference. So to check to see if A has a common ratio, divide each term by the previous term. So the first term I can't divide by a previous term because that's the first term. But the second term I can divide by the first term to see if there's a common ratio. And I get 2. 6 divided by 3 is 2. I look at 12 divided by 6. I look at the third term divided by the second term, and I get 2. I look at 24 divided by 12. I get 2. I look at 48 divided by 24. I get 2. So there is a common ratio here, and in that case, it is a geometric sequence. So the sequence 3, 6, 12, 24, 48 has a common ratio, and so therefore the sequence is geometric. For the sequence 3, 6, 9, 12, 15, how can you get from one number to the next? Which this one is this is letter B. Okay, I'm like, where did that come from for a second? So for the sequence 3, 6, 9, 12, 15, however, what we're actually doing here is that we're increasing by, if I divide 6 divided by 3, I'm getting 2. If I do 9 divided by 3, that's not going to be 2. So I'm going to test to see if it's an arithmetic sequence. So let's see if there's a common difference. I'll do 6 divided by 3, I get 3. 9 minus 6, that's 3. 12 minus 9, that's 3. 15 minus 12, that's 3. So I'm adding 3 each time to get the following term. So because I have to add 3 to each term to get the next term. Because the sequence 3, 6, 9, 12, 15 has a common difference, this sequence is arithmetic. So if we're adding a number each time, that's going to be arithmetic. If we're multiplying by a number each time to get the following term, it's going to be geometric. Now, how do we, once we identify that a sequence is geometric, how do we write recursive and explicit formulas? So first what you need is, regardless of whether you're going to write a recursive or an explicit formula, you always need the initial value and the common ratio. So the initial value in this sequence, 2, 4, 8, 16, is 2. So that's a sub 1. Your common ratio here, we identify 4 divided by 2, that's 2. 8 divided by 4, that's 2. 16 divided by 8, that's 2. So what we're doing is that each following term is being multiplied by 2. So your common ratio here is 2. So we have our initial value and our common ratio. So how do we set this up? So let's go to the next page on your packet. A sub n. So here we go. Let's start with recursive. We'll finish recursive and then we'll go to the explicit formula. So you have two parts for the recursive formula. You have your first term, and you have your nth term, okay? So if I, for example, if I have the first term, a is equal to 2, my nth term is going to equal the previous term times r, and that's what I put up here. A sub n is your nth term. If you read this formula, how do you read it? Your nth term is going to equal your previous term, a sub n minus 1, times your ratio. So say, for example, if I want my sixth term, I need the fifth term in order to find that. So for the recursive formula, you need the previous term in order to find your nth term. So that's how I would set that up. You would substitute the starting value for a sub 1, and then you would substitute the common ratio in the general equation that we had in the previous page. For the explicit formula, everything is written in one equation. So a sub n is equal to your first term times r, your ratio, to the power n minus 1. So we just plug those values in. A sub 1 is 2, and your ratio here is 2 as well. Okay, so your recursive formula has two parts again. You have your a sub 1, and that's equal to a sub, your nth term is going to equal the previous term times 2. And for your explicit formula, you can basically, you don't need the previous term. You can find the nth term just directly. You say, if I want the eighth term, I would plug in a to the eighth term is equal to 2 times 2 to the power 7 minus 1. Okay, and for this one, each term kind of builds on the previous term. So in order to find a sub 2, I would need a sub 1. I need a sub 2 minus 1 times 2, which is equal to a 1 times 2. Then I would plug in a sub 1, which I already have. That's equal to 2 times 2, which is equal to 4. So a sub 2 is equal to 4. But if I want the third term, I would need to plug in the previous term. So if I plug this in, a sub 3 is equal to a sub 3 minus 1, right? And that's times 2. And that's equal to a sub 2 times 2. And in this, to get the third term, I need the previous term. I need the a sub 2. And we found out from the previous line that a sub 2 was 4. So that's equal to 4 times 2, which is just 8. Okay, so yeah, I can just multiply 2 each time, but this is how we write it mathematically in a recursive formula. So for the explicit formula, I don't necessarily need the previous term. I just need the first term and the nth term. And so that's what I do. I just plug in a sub 8 is equal to 2 times 2 to the power of 8 minus 1, which is equal to a sub 8 is equal to 2 times 2 to the power 7. I evaluate 2 to the power 7 and multiply that by 2. Okay, and 2 to the power 7 is 128 times 2 is 256. Okay. Now, what if I wanted to write an explicit formula? Let's get practice. Actually, for this one, we're going to practice writing the sequences using a recursive formula and an explicit formula as well. So it says, write a recursive formula and an explicit formula for the sequence below and find the eighth term of the sequence. So here's your sequence. So first I need to find the common ratio. I need to find what 18 divided by 14 is. 18 divided by 14 is... No, sorry, what did I say? 18. 84 divided by 14 is... 84 divided by 14 is 6. 504 divided by 84 is also 6. And 3024 divided by 504 is also 6. So each consecutive term is being multiplied by 6. So we can confirm that that's definitely geometric. Now, every geometric sequence has a starting value and a common ratio. We know that. To find the R value, find the quotient of two consecutive terms. The common ratio for the sequence is 84 divided by 14, which is 6. And then, which we found, okay? Which we found out here. We can fill all that after you identify that stuff. And your first term here is 14. So to write either, you need a sub 1, which is your first term, and you need R for your both your explicit and recursive formulas. Your R here is 6, okay? Now, it says, circle the recursive formula for the sequence and underline the explicit formula. So remember, you need, in order to read these, I know these equations can be a little bit tricky to read. This is basically saying that a sub n, or your nth term, is equal to your a sub 1 times r to the power n minus 1. So this is saying that your first term is 14. And in this case, this is true. This is an example of your explicit formula. Your 14 is a1, and r here is 6. So a1 here is 14, and r here is 6. And that does match. And so for this one, we're saying that a sub n, your nth term, is equal to 14 with a subscript of n minus 1. We're not really calculating here if we do that, so that doesn't really make sense, so we can't use this formula. And a sub n is equal to your previous term times your common ratio. So any equation that uses the previous term is going, so if you see this setup and you notice that in the equation that the previous term is in there, previous term is written as a sub n minus 1, you know that's going to be recursive. So let that be a signal for you, okay? So here we go. For number 23, it says substitute 8 for n in the explicit formula and determine the 8th term of the sequence. So here's the explicit formula right here. You have a sub n is equal to a1 times r to the power n minus 1. We know in this sequence here that your first term was 14, your r was 6, and the term that you're looking for is going to be 8. So n here is going to be 8. That means when n is 8, a sub n, or a sub 8, is equal to your 8th term. Okay? So I'm going to erase this part right here. So if I'm looking for a sub 8, that's going to equal to, I'm just going to basically plug all this information here. A sub 8 is equal to the first term, 14, times my ratio, which is 6, to the power of n minus 1, which is 8 minus 1. And then I just simplify that. A sub n, I don't multiply this, I just leave this as is. This a sub n just literally means this is my 8th term. This is equal to 14 times 6 to the power of 7, because 8 minus 1 is 7, so that simplifies that. And so a sub n, once I figure this out, 6 to the power 7 times 14 is going to be 3,919,104. And that's going to be your 8th term in this sequence. Now, in problem 4, we're going to write geometric sequences as functions. A geometric sequence has an initial value of 2 and a common ratio of 3. So I just rewrote that here. A sub 1 is 2 and r is equal to 3. Write a function to represent the sequence and graph the function. So to write a function, in order to write a function that represents the sequence, we're basically going to use the explicit formula for a geometric sequence. So we've identified that a sub 1 is 2 and the common ratio is 3. So which one of these has a sub 1 as 2 and a common ratio of 3? This one has an a sub 1 of 3, because this is what the formula looks like. So remember, in an explicit formula, your a sub n is equal to a sub 1 times r, your ratio, times n to the power n minus 1. So your coefficient basically is telling you your first term. Okay? And in all of these, your first term here, for the first one, a sub 1 is 3. For this equation, a sub 1 is 2. And for this one, this doesn't even have your a sub 1 here. So that's not even, this is using your previous term. So we already know that if it's using the previous term, right, this is recursive. And so your r here is going to be the factor that's being raised to a power. So r here is 2 and r here is 3. Which one matches a sub 1 is 2 and r is 3? That's going to be the second one. So when we write a function, we're basically just going to substitute a sub n, and we're going to write f of x instead. So instead of a sub n, use f of x and x. A sub n, I would say, and n, use f of x and x. So wherever we see a sub n, wherever we see n, we're going to substitute for f of x, and we're going to substitute n for n for x. And so when I rewrite that, a sub n is equal to 2. Everything stays the same. We're just changing the variables. So a sub n becomes f of x, and n becomes x right there. Okay? And that's your equation. Now, on the next page, it says to substitute 2, 3, and 4, and 5 for x in your function from exercise 19 to find the value of f of x for each value. So f of x, remember we said, is 2 times 3 to the power x minus 1. All you have to do is plug in your inputs into your equation. So I want to find f of 2. Wherever I see x, I'm going to plug in 2, and I'm going to simplify that. So 2 times 3 to the power of 2 minus 1 is equal to 2 times 3 to the power 1. This simplifies to 1, and that equals to 6. F of 3 is equal to 2 times 3 to the power of 3 minus 1, which is equal to 2 times 3 squared, which is 18. F of 4 is going to be 2 times 3 to the power 4 minus 1, and that's going to equal 2 times 3 cubed, which is 54. F of 5 is going to equal 2 times 3 to the power 5 minus 1, and that's equal to 2 times 3 to the power 5, which is 162. And then once I plug in my inputs, these are my outputs, and I just plug that into the points, and I just graph it. Okay? And so again, this is an example of a exponential function. All right, lesson check. A friend says that the recursive formula for the geometric sequence is a sub n is equal to 1 times negative 1 to the power n minus 1. Explain your friend's error and give the correct recursive formula. The formula here does not have an initial condition, so it is a recursive formula. Write the recursive formula for the sequence. You find the common ratio. You need a sub 1 is equal to 1, and a sub n is equal to the previous term. Your nth term is equal to the previous term times negative 1. So remember, for recursive formulas, you have two parts: your initial condition, which is written separately, and your nth, and you have to remember that your nth term depends on your previous term. For an explicit formula, you have one equation, and your initial condition is part of the equation. All right, so the friend's error is that the friend wrote the explicit formula for the geometric sequence rather than the recursive formula. Your homework is to complete 7-8, which is the homework attached in the email. If you have any questions, please let me know. Assalamu alaikum.